almost cried when I found out when he told me.
You have to have it like
After school, I have to go to a meeting really quickly,
and it mixes it up. But
hopefully it won't be long.
you have to.
Yeah, she fixed it and then emailed.
All right, we're live.
Mr. Dolan.
So, we just learned a new theorem. Really, we learned two, CCP, but we'll get to that. But the big one is the Isosceles triangle theorem, which states if two sides of a triangle are congruent, aka if you have an isosceles triangle, right, then the angles opposite those sides must be congruent. So this implies this. We also learned that the converse for this is true. Not all converses for all theorems are true, but this one goes both ways. So not only do the sides imply the angles, but the angles also imply the sides. So when we use the isosceles triangle theorem, we call it that, right? The shorthand for that is isosceles triangle theorem, right? And then when we use the reverse of that, we call it the isosceles triangle theorem converse, okay? Which is a mouthful. So you'd write converse after this.
I wear those shoes.
Okay. Cool. So hint, hint, hint. That's a new thing we learned. Might be helpful for the isosceles triangle proof worksheet. Okay. Here we go. So we're given that D and E are congruent angles. So we're going to put that into our diagram. Noah Schlager, sit in Macy's seat.
All right.
You haven't been doing very well in your spot.
What? Please don't switch the green. Switch like him in.
Just today.
I do need that.
Who sits here? Who? Riley. Oh yeah. I can't move her. I think I might not.
They also give us that A is the midpoint of DB.
What did I do?
You're just mean.
Just me.
A is the midpoint of DB. So if A is the midpoint of DB, what does that tell us?
It's a line.
EA and AB are the same? Yes, DA. I thought you said EA. Sorry. These two are congruent. Right? Because that's what the midpoint means. It cuts it in half, right? So those must be the same. We also know that B is the midpoint of AE. So here's AE. And if B is the midpoint, then it cuts these in equal half. So this must be the same as that. So I'm going to use the same mark for both of those. Okay. So now we're going to prove that triangle CDA is congruent to CEB. Now, you should not do this. I'm just doing it so you can see what our goal is. Because letters are hard, right? Let's do this. CDA is this triangle. And CEB is this triangle. So our goal is to prove those two the same, right?
Yeah.
Well, do we have enough information to do so right off the bat? No, we've got an angle and a side. So if we can get another angle, we're good, right? Because then we'd have angle, angle, side. If we can get this side, then we get side, angle, side, right? So how can we get some more information about these triangles? I'll give you a hint. Isosceles triangle theorem states that if two sides of a triangle are congruent, then their opposite angles are congruent. The converse is that if we have angles congruent, then the sides are congruent. What do you see? Take some time to look at it. There's a couple ways to look at this diagram. You might not see it right away. Don't forget to look at the big picture.
What?
Quinn.
AC and BC will be like the same.
AC and BC are the same. How do you know that?
The opposite sides of the angles.
So you're saying because these angles are the same?
Yeah.
Okay, so here's the deal. This angle is part of this big triangle, and that's how those two are connected. So it won't be this side that's the same with this side. If these two angles are the same, then these two sides would match, right? But we don't know that. These two angles are related in this big triangle. So that means opposite side is here. and this one opens up to here. So this and this are congruent. Does everybody see that triangle DEC, the big triangle, is isosceles? It has two angles that are the same, so it's going to have two sides that are the same. Again, look at the big picture. I know a lot of you guys thought that angle was just part of this triangle, but it's also part of the big triangle, isn't it, right? So the big triangle sides are going to be the same. Does that make sense? Okay. So, did we use the isosceles triangle theorem or its converse? The theorem says if we're given two sides, well, we weren't given the sides, right? So what do we got?
No, we use the converse.
We use the converse, right? Converse starts with the angles and goes to the sides. So we're going to write by isosceles triangle theorem converse. I know it's a mouthful, but here's how you can abbreviate isosceles triangle, right? Takes two big words out of there. THM is short for theorem, right? A lot of people have been confused by that. Sorry. Seems very consistent across my classes. So by that, we know that CD is congruent to CE. Great. So we got another side. After you get new information, ask yourself, do I have enough to prove triangles congruent? And if you do it. If not, keep looking for more information, right? Can I prove the two maroon triangles congruent? I can now, right? Side, angle, side matches up for both. So now I can say by side, angle, side, those two triangles are congruent. So I'm going to write that. By, side, angle, side. And to be clear, the sides I'm talking about are the blue side, the pink angle, and the green side, right? Sorry, I'm very zoomed in right now. There we go. By side, angle, side, I know that the triangle is congruent, so I'm going to write that. Triangle. When I write my first triangle, I always try to do it in alphabetical order. You don't have to, okay? A, C, D would be alphabetical order. It just makes it easier for grading if we're all consistent. But you don't have to be. You could have written DCA or CAD or whatever you wanted here. But once you write what you've written here, you have to match up the letters on the other side, okay? So angle A on this triangle is this angle right here. It's made up of two sides, the green side and the unknown side. So if I go to the other triangle and I find the green side and the unknown side, they make up angle B. So that means A and B must go together. So everybody getting the hang of that? Matching up the letters? Okay. C on this triangle is made up of this side, the blue side, and the unknown side. So if I go blue and unknown, well, it's also C. So C goes to C here. D is green and blue. Green and blue is going to be E. Okay? If you wrote, pretend you said CAD over here, then you would have written CBE over here in that order. Okay? Does that make sense? Now, the other theorem we learned other than isosceles triangle theorem is called corresponding congruent parts theorem. We call it CCP. CCP says that if the triangles are congruent, which they is, right, then their parts must be congruent. And that's, oh wait, hold on. We just proved the triangle's congruent. We're done. Boring. I thought we were going to do something more of that. We'll do something more of the next page. We're done. They wanted CDA and CBE. So you could rewrite this like that, CDA. So if I write CDA, C goes with C, right? So I'd write C over here. D is my next letter. D went with E. And then A would be my last letter and went with E. So there we go. Fair enough. We got what they wanted. Swag glass. I think we can all agree that the hardest part of this, again, there's new stuff, so there's some stuff that's still hard, but the hardest part is probably seeing it, right? Being able to see that, oh, those two angles mean that these two sides are the same, right? Being able to see that that's part of the bigger triangle, right? Don't forget to look at the big picture, okay? A lot of times those angles apply to not just this triangle, but also the big triangle, right? How do you feel about number one? Feel okay? Dece, I'll take Dece. This is new. Dece is really good. Yes? Yes, you may. Number two, here we go. First off, mark your diagram with what they have. CA and CB. The way I'm going to mark that is with this. Because if I were to mark it anywhere else, it would make things look like they're congruent that aren't. So if I were to put a line here to say that CA is the same thing as CB, well then it would look like I wrote CR as the same thing as something, right? And I can't put a line there because then it would be RA. So to get the whole thing, I just kind of wrap it in a big bracket, okay? AR congruent to BS. AR is this segment, so I'm going to mark that. And BS. We also know that DR and AC are perpendicular. So what does that mean? Grandpa SquarePants? What does it mean by perpendicular? Never chase after, no, that's congruent. Never chase after a bus, especially one going up at a 90-degree angle, right? Rock bottom? I've been saying this for an entire year, yes. So that means these are perpendicular, they're going to hit at 90. So DR is this, and AC is this. That means they hit at 90, which means this is 90, and that is 90. Same thing with DS and BC. Those are both 90. Yay! All right, so now we're going to prove DR and DS the same. Again, don't you do this. I'm marking it so you can see our target. DR is this, and DS is this. I'm not saying they're congruent. I'm just showing you what our targets are. We're trying to prove that they're congruent, okay? That's what this is. So we don't know they're congruent yet. Our goal is to prove them congruent. So here's what I think. I think I've got plenty of triangles, so I don't need to go and drop like a perpendicular to make more triangles, right? Let's work with the triangles we have. I know if I can prove this and this the same, those two triangles congruent, then their parts will be congruent, and I get this, right? So how can I prove those two the same? Well, it looks like I've got an angle and a side. It's 90, so HL's on the table, right? If I can figure out these two are the same, I win, right? Because then I have hypotenuse leg. Or I can figure out another side and get side, angle, side. Or I can figure out another angle and get angle, angle, side. So I need more information about these triangles. Is there a way I can get it? What do you see, Peters? Vertical angles? Ooh, where?
Down by D.
Right. So a very common mistake, and I'm glad you made this, is to say that this and this are vertical, and they're not. Remember, verticals are made of x's. So if this were extended and this were extended, then we'd have vertical angles here. Does that make sense? Not quite. They are going to be congruent though. Not to the vertical level. But thanks for pointing that out. What else can we do? Don't forget to look at the big picture. Does everybody see that A, B, C is an isosceles triangle? Well, if the sides are the same, shouldn't their opposite angles be the same? So guess what? There it is, bud. It's just the reverse of what we did last time, right? So last time we used the converse, right? This one's the regular theorem, right? If they give you the sides, you can get the angles, right? So by isosceles triangle theorem, we know angle A is congruent to angle B. Yay! Now do we have enough information to prove these two triangles congruent? Oh yeah. Angle, side, angle. Angle, side, angle. Let's do it! I know the two triangles are congruent. I'm going to call it ADR. And the other one, I'll call, let's see, A matches up with what? We've got pink and unknown, right? Pink and the hypotenuse. Pink and the hypotenuse. Ooh, that's a good band. I think you need some workshopping, right? Because obviously pink is already an artist. Like something in the hypotenuse. That's good. That's good. Band-aid. pink in the hypotenuse. Pink in the hypotenuse. A is going to go with B. D, this angle right here. Hypotenuse and unknown leg. Hypotenuse and unknown leg. D goes with D. R is pink and unknown leg. Pink and unknown leg is S. All right, so we want to prove the parts congruent, right? DR and DS, which are parts of those triangles, right? And if you look, DR and DS are in the same relative location, right? Which means they're corresponding. So by corresponding congruent parts, CCP, DR is congruent to DS. Ta-da!
With the Nintendo DS.
Wow.
How do you like that? You see it now? We're gonna back up and go over it again.
I like the
Wait, so-
last test more.
Yeah, I know. That was like this part.
Through my initials.
So Natalie, the last test was like, we just did that.
Yeah.
Yep.
Wait, so like to use CCP, like in order to use it, when you like use like a property like ASO or SSS something like that, if it has like the same like lines that you have to prove, then CCP pretty much like because it has DR and
Yeah, okay, so I think this will answer your question. So guys, there isn't really a do step 1, do step 2, do step 3 type of deal for this. First of all, it's not how it teach math. Second of all, geometry just doesn't work that way, right? Every problem's different. But the concept is this. One, if you're talking steps, right? Get as much information about your triangles as possible. For instance, we found that A and B are congruent, right? And then ask yourself, can I prove triangles congruent? If you can, do so, right? And after you prove the triangles congruent, their parts will be. So my goal was to get these two triangles congruent because if they're congruent, then their parts are, which is what I want, right? So after I get the triangles congruent, I can say their parts are congruent, which is what CCP is. And I can write the parts that I want. The parts are always the parts that correspond. That's what the C in CCP stands for. Corresponding congruent parts. Corresponding means same relative location. Does everybody see how DR and DS are in the same spot? So after we meticulously put our letters down, we can check letters to see what's congruent. That's what CCP says, okay? So again, the goal is get as much information about your triangles as possible, prove them congruent, and then get their parts congruent, okay? Let's take a look at 3. Actually, yeah, 3. Here we go. This one you're going to do on your own.
Oh no.
We're going to get the information down together though. So BCF and DCE are congruent. Ooh, actually, you're not going to do this one on your own. Never mind. I need to teach you something first. We'll do the next one on your own.
I wouldn't be able to do it by myself.
We need to try doing it though, because you'll never be able to know that you can do it by yourself until we try multiple times. And you're going to fail, and that's okay. That's part of the process of learning. And then DCE, which is this angle,
There's a circle that I
are congruent.
There's a line from the 19.
Doesn't look like that. We know that C is the midpoint of BD.
Your hair was like so much curly.
What does C being the midpoint of BD mean? What does this mean?
Middle.
It's in the middle of BD, which means what?
DC and CD are
Yeah, these two are congruent, right? Dollarschlager, put the phone away.
yeah.
You're good, but you're not this good. There's not a single one of you in here that can pay 0 attention to get this. And let's be honest, a lot of you guys are way worse than that, right?
Yeah.
Okay. And that's normal. That's not meant to be an insult. It's like, would anyone expect you to walk into a class you've never been to before and be able to get the answers?
Couldn't
No.
say
The
I'd do it.
Pi squared.
No. Not a single one of you can. So if you were convinced that I can pay no attention and still get this, what? Like, come on. There's just no freaking way. All right, so CE congruent CF. Yeah, you guys know how my math class is. I don't BS you guys. We do real stuff in here. If you can figure it out without having to learn it, why would we have the class? Right? So I give you stuff that takes some actual thinking. CE is congruent to CF. So that means this is true. Again, use 2 tick marks there because we don't know if they're congruent to the green, right? It's a separate statement. Okay, cool. So we want to prove ABD isosceles. Well, ABD is the big triangle, right? And to prove it isosceles, it has to fit the definition of isosceles. Remember, the definition of an isosceles triangle is this: 2 sides the same. So if we can prove that AB is congruent to AD, then by definition, that's an isosceles triangle, right? Cool. So, how do you solve a problem like Maria? Let me show you. My thought is, if I can get that angle and that angle to be equal, then I get the sides for free, right? You with me? If that angle is congruent to that angle, then it opens up into the same side. So those sides will be free, and then we have an isosceles triangle. So I want to get these angles to match. In other words, I want to get these 2 triangles to be congruent, right? Now, do I have enough information? I've got side and a side. I don't have this angle congruent to that angle, unfortunately. But there's a way to get it. Notice that BCF, that angle, is made up of 2 parts. BCF is this pink angle right here. What 2 parts is it made up of? What 2 angles? BCE, right? I'm going to color that in blue so you know what I'm talking about. And what's the other angle? ECF, very good. So I can write this. Why am I allowed to write that? Angle addition postulate, right? The 2 pieces make up the big one. Don't write this down. We're going to do a shortcut, okay? I'm showing you the logic behind it, okay? Angle addition postulate says the big angle is made up of the 2 little ones, so you can add them up, right? Does that make sense? The 2 little angles add up to the big angle, right? Okay. I can say the same thing for the other pink angle, DCE. So for the other pink angle, and remember, they're pink because they're both the same color, or they're both congruent. So it's made up of this angle. What's that angle? DCF, right? And it's made up of the same green angle, right? Again, this is all angle addition postulate. Now check it out. If these both equal pink, and these both equal pink, don't they equal each other? So I'm going to write that. You don't have to. Right? And then if I subtract ECF from both sides, what do I get? BCE equals DCF. So it turns out the light blue and the dark blue, same angle, right? I just proved it. So what I'm going to say that encapsulates all of that is I'm going to say by angle addition postulate, I know that BCE is congruent to DCF. Okay? I don't need to see this on a quiz, but that's why it's angle addition postulate. These 2 add up to the pink, these 2 add up to the pink, so they add up to each other, and then what's left over is what I want. Okay? So we just say by angle addition postulate, cut to the chase, I know those 2 the same. Okay? If you need to write it all out, go for it. To logic your way through it. So now I know that those angles are the same. Do I have enough to prove the triangle's congruent? Left side triangle, I have a side angle side, right? And I've got a side angle side there. So yeah, I do. So by side angle side, again, the sides I'm talking about are the green sides, the light blue / dark blue angle, which we found out were the same, right? And then the dark blue side. Right? So by side angle side. Yes?
Oh, never mind.
Okay. Triangle over here. I'm going to write it as BCE. Now let's match up our letters. B is made up of the green side and the unknown side, right? So if I go to green side and unknown side, that's going to be angle what? D. So D is in dog. C on this triangle is made up of the green side and the dark blue side, right? So if I go green side, dark blue side, C goes with itself, right? E, dark blue and unknown goes with that. Go. That's not what we wanted. We wanted to prove ABD is isosceles. Again, my goal was to get these two angles to be congruent. Well, if the triangles are congruent, aren't their parts congruent? So check it out. I know that this angle B is congruent to this angle D because B and D are corresponding, aren't they? So by CCP, angle B congruent to angle D. See how they're corresponding, same relative location? Right? First and first? Feel okay, McKenna?
Yep.
Yeah, okay. And now I can say, well, if those are the same, then these sides must be the same. So let's say that. Is this the converse or the regular theorem for isosceles triangle theorem? Starting with the angles? Yeah, starting with the angles is the converse. So we're going to say by isosceles triangle theorem converse, we know that AB is congruent to AD. Those two sides are the same, right? And then that fits the definition for isosceles, doesn't it? Right? If these two sides are the same, which we just proved, then doesn't that mean the whole thing's isosceles, right? So we're going to say by definition, then, it's isosceles. Right? When we say by definition, I think a lot of you guys get confused by what that means. It means it fits the definition, right? Isosceles says I have to have two sides the same, and now that I've shown that, I can say it fits the definition. So I can call it that, right? By definition, ABC, or ABD, I should say, is isosceles. Oops, sorry. Okay, we're going to back up and go over it again.
The mailman hit my dog one time.
Like with his truck or with his like hand? Or
Killed it.
with his hand?
No.
Killed what? Hold
Also,
up.
a kid from my old school's dad got ran over by the mailman.
Yikes.
Also, I used to have a Saint Bernard and it got hit by a semi and it lived for 2 years after that.
That's amazing.
Mars was like one of the best dogs ever.
Same day delivery.
He started drooling a lot though.
You started drooling a lot? I hate when that
No,
happens.
drooling.
Like, they seem really cool and then they start drooling a lot and you're like, oh man,
Yeah,
we
my
can't be
dog
friends
started
anymore.
drooling.
Right.
And I was dying.
So, first off, our goal was to get
Same
these.
day delivery to heaven.
Our goal was to get these two triangles to be congruent. All right, shut up. You don't need to put an exclamation point in the end of every sentence, especially while I'm teaching. All right, so we wanted to prove these two triangles the same because if we know they're the same, then their angles are the same, and if their angles are the same, these sides are the same, and if those sides are the same, then we have an isosceles triangle, right? That's the idea. So, by angle addition postulate, I know these two angles are the same, which then tells me by side angle side, these triangles are the same. And if the triangles are the same, then their angles are the same. And if their angles are the same, their sides are the same. And if their sides are the same, we have an isosceles triangle. So let me walk you through that. Angle addition postulate gets us these. Side angle side says the triangles are congruent. And if the triangles are congruent, I can use CCP to say their angles match up. And then, by the converse of the isosceles triangle theorem, if I have the angles, I have the sides, right? Cool with that? And then by definition, if those two sides are the same, then that's an isosceles triangle. I'm going to do it one more time. By angle addition postulate, I prove those two angles the same, which then allows me to say the triangles are the same by side angle side. Okay? Good up to there? With me up to there? Then, by CCP, if the triangles are the same, their parts are the same. So that means B and D are the same, right? And if B and D are the same, that gets me my sides by the theorem we learned earlier, right? And that means that's an isosceles triangle. That fits the definition. How do you feel? Dece? Not at all? Natalie, did I have you up to here? Did I have you up to here?
I don't know.
Okay, great. See, that's how we diagnose. Okay? So I had you up here, right? See how B and D are in the same spot? CCP says if they're in the same spot, then they're congruent.
Okay.
So, for instance, CE as a line segment would be congruent to CF. Here's CE, CF. Oh, look, they are. Isn't that magic? If you line up your letters correctly, you get all that for free. So, after that, I can say if those angles are the same, then those opposite sides are the same, right? Does that make sense? Right? We learned that if we have this, then it implies this, right? So we get these sides, right? And that means the whole thing is isosceles, because an isosceles triangle is anything that has two sides the same. So by definition, better? I'll take better. All right. 4. Ooh, 5 could be homework, not 4. All right, let's do 4 together.
No.
LM and OP. They're congruent. So LM is this, OP is that. NLO is this angle. And NOL is this angle. Ooh, I see something already. We got an isosceles triangle here, don't we? Okay. But we won't mark it yet. We also know that ML and LO are perpendicular. So ML and LO intersect here. So yeah, it's gross looking, but it's true. That just means that that blue angle is less than 90, and it's going to add up with this other one to make 90, right? That might be something to think about. Same thing here. Now, our goal is to prove that MN and NP are the same. So we're trying to prove that these two are the same. Again, I'm not saying they are the same. I'm saying that's my goal. Okay? Everybody cool with that? Now, which triangles contain both MN and NP, right? Or not both, I should say contain more. Well, it's this triangle, right? So if I can prove these two triangles the same, their parts will be the same, right? CCP. So I need to prove this triangle and this triangle the same. There's lots of ways to do it. You could even draw perpendicular if you wanted, make some right triangles, but we don't need to. Didn't we say that this was an isosceles triangle? How do we know that this has to be isosceles, this triangle right here? How do we know that?
Isosceles triangle theorem, Converse.
Yep, exactly. It says if we have the angles, we get the sides, right? So let's write that. By isosceles triangle theorem Converse, we know that Ln is congruent to On. Is everybody cool with that concept? Do you see it? We've got an upside down isosceles. Two angles are the same, which means two sides will be the same. Cool? Now look down at our triangles. We've got two sides. Not enough to prove it's congruent yet. If we had a 90 degree there, if we knew that, then we could do HL, right? HL is hypotenuse laid, but we don't know that for sure. Okay? Turns out later we'll be able to prove that it is, but we don't need to right now. Is there a way we can get some more information on these triangles? What about this angle right here? And this angle right here? If we could prove those congruent, then we'd have side angle side, right? Don't we know that the blue angle and the green angle add up to 90? What theorem says you're allowed to take the two bits and add up to the whole thing? It's not theorem, it's a postulate. Yeah?
Addition.
Something addition postulate. Angle addition, very good, because we're adding angles. Very good, Katie. Same thing here. Blue angle and pink angle must add up to 90, right? Are you following me? Okay, that's angle addition postulate. Well, if that equals 90 and that equals 90, don't they equal each other? Again, you don't need to write this. I'm just showing you the logic behind it. Because I'm doing shorthand here. I'm just calling them by their colors, right? All right. So now if I subtract blue from both sides, what do I get? Pink equals green, right? So by angle, so all of that is just to say by angle addition postulate, I know green angle equals pink angle. What's the name of the green angle? Looks like MLN, yeah? You can't see what I'm doing. So by angle addition postulate, I know MLN is congruent to the other angle, which is PON. How about them apples? Getting it? Marissa? Now do I have enough information to prove the triangle's congruent? Side, angle, side, side, angle, side, right? Are we good up to here? Because after this, we're just going to say triangles are congruent, so their parts are congruent, we win, right? Are we good up to here? Seeing this, right? Because the angles, right? Triangle theorem, Converse. Isosceles triangle theorem, Converse. AP, angle addition postulate, says if those two add up to 90 and those two add up to 90, then they must add up to themselves, right? And if I subtract, I get this. So green and pink go together. That's angle addition postulate. Now we're going to say by side, angle, side, side, angle, side, the two triangles are congruent. So I'm going to go LMN, congruent to, looks like L on this triangle is made up of the red side and the blue side. So red side and blue side goes with O.
Can you move it?
Yes, sorry. Thank you for telling me. Please tell me that every time, guys. M, this is like one of the few classes that doesn't, if Macy's not here. M is this angle. That's made up of the red and the unknown. Red and unknown is P. And then N is made up of blue and unknown, blue and unknown. So N is congruent with itself. Now, we want to get MN and NP together. Well, here's MN, here's NP. Are they? Yes.
Don't you use CCP then?
Yeah, you will use CCP, right?
Yeah.
Corresponding congruent part. So by CCP, MN congruent to NP. It's 5 bucks.
Isn't it PN?
It should be PN, and then we should reverse it. They wrote this incorrectly. And by they, I mean me. I was really lazy and I stole letters by copying and pasting from old documents, and I found an NP, and I was like, oh, I'll put that in there, when I really wanted a PN. Yeah. But it's okay. I'll be better. 5 is for homework.
Yes.
I want you to try it for real. Let's label the diagram together. This means A, D, E, B is a line. That's all it's telling you. So it's telling you those points are collinear, okay? So you can assume that it's a line. A, E, and DB are the same. So check it out. That means this. I bet you're going to use segment addition postulate, aren't you? Similar with the angles, right? These two add up to get this big guy. These two add up to this big guy. Right? CDE, CED. CDE, CED. I bet you can see stuff right away. CDE is an isosceles triangle, isn't it? Is that going to be by the converse or the regular theorem? Mark.
Converse.
Converse, because we start with the angles. So we're going to get some free sides. Everybody loves free sides. Apps and zerts, baby. Apps and zerts. Try number 5 for real on your own. It'll help for you to struggle with it and come back in. But if you don't try it at all, you won't struggle and you won't get better.
Yeah, I don't have yellow gloves, I have like yellow gloves. I have them with me and I don't have
going poorly, I feel like is very high. So I'd rather not.
Of course it's gonna go poorly. I'm in here.
That's why.
I'm literally not.
Oh, I'm not even home.
I know. That's when my parents' marriage fell apart.
Oh, that's sad.
I'm a failure.
Try 5. Do we have a lot of time left? Did I finish this earlier than the last period?
We have
No.
a minute.
Go. Go away.